In northern Chile lies the Atacama Desert, the driest place on Earth. Some regions here haven't seen rain for hundreds of years. It's a landscape so harsh, so alien, that NASA has tested Mars rovers on its soil. But for astronomers, this desert is paradise. Its high altitude, thin atmosphere, and crystal-clear skies make it the perfect window into the universe. The Very Large Telescope, VLT, is an astronomical facility operated since 1998 by the European Southern Observatory, located on Cerro Paranal in the Atacama Desert of northern Chile. It consists of 4 individual telescopes, each equipped with a primary mirror that measures 8.2 meters, 27 feet, in diameter. These optical telescopes, named Untu, Kian, Melipal, and Yepin, all words for astronomical objects in the Mapuche language, are generally used separately but can be combined to achieve a very high angular resolution. The VLT array is also complemented by 4 movable auxiliary telescopes, ATS, with 1.8 meter, 5.9 feet, apertures. The VLT is capable of observing both visible and infrared wavelengths. Each individual telescope can detect objects that are roughly 4 billion times fainter than what can be seen with the naked eye. When all the telescopes are combined, the facility can achieve an angular resolution of approximately 0.002 arcsecond. In single telescope mode, the angular resolution is about 0.05 arcseconds. The VLT is one of the most productive facilities for astronomy, second only to the Hubble Space Telescope in terms of the number of scientific papers produced from facilities operating at visible wavelengths. 3. Some of the pioneering observations made using the VLT include the first direct image of an exoplanet, the tracking of stars orbiting around the supermassive black hole at the center of the Milky Way, and observations of the afterglow of the furthest known gamma-ray burst. The VLT consists of an arrangement of 4 large, 8.2 meter, 27 feet, diameter telescopes, called unit telescope, or UTs, with optical elements that can combine them into an astronomical interferometer, VLTI, which is used to resolve small objects. The interferometer also includes a set of 4 1.8 meter, 5.9 feet, diameter movable telescopes dedicated to interferometric observations. The first of the UTs started operating in May 1998 and was offered to the astronomical community on April 1, 1999. The other telescopes became operational in 1999 and 2000, enabling multi-telescope VLT capability. For 8-meter auxiliary telescopes, ATS, have been added to the VLTI to make it available when the UTs are being used for other projects. These ATS were installed and became operational between 2004 and 2007. The VLT's 8.2-meter telescopes were originally designed to operate in 3 modes. As a set of 4 independent telescopes, this is the primary mode of operation. As a single large coherent interferometric instrument, the VLT interferometer or VLTI, for extra resolution. This mode is used for observations of relatively bright sources with a small angular extent. As a single large incoherent instrument, for extra light-gathering capacity. The instrumentation required to obtain a combined incoherent focus was not originally built. In 2009, new instrumentation proposals were put forward to potentially make that observing mode available. Multiple telescopes are sometimes independently pointed at the same object, either to increase the total light-gathering power or to provide simultaneous observations with complementary instruments. The UTs are equipped with a large set of instruments permitting observations to be performed from the near-ultraviolet to the mid-infrared, i.e. a large fraction of the light wavelengths accessible from the surface of the Earth. With the full range of techniques including high-resolution spectroscopy, multi-object spectroscopy, imaging, and high-resolution imaging. In particular, the VLT has several adaptive optics systems, which correct for the effects of atmospheric turbulence, providing images almost as sharp as if the telescope were in space. In the near-infrared, the adaptive optics images of the VLT are up to 3 times sharper than those of the Hubble Space Telescope, and the spectroscopic resolution is many times better than Hubble. The VLTs are noted for their high level of observing efficiency and automation. The primary mirrors of the UTs are 8.2 meters, 26.9 feet, in diameter, but, in practice, The pupil of the telescopes is defined by their secondary mirrors, effectively reducing the usable diameter to 8.0 meters, 26.2 feet, at the Naismith focus and 8.1 meters, 26.6 feet, at the Cassegrain focus. The 8.2-meter diameter telescopes are housed in compact, thermally controlled buildings, which rotate synchronously with the telescopes. This design minimizes any adverse effects on the observing conditions, for instance from air turbulence in the telescope tube, which might otherwise occur due to variations in the temperature and wind flow. It had long been ESO's intention to provide real names to the 4 VLT unit telescopes, to replace the original technical designations of UT1 to UT4. In March 1999, at the time of the Paranal inauguration, for meaningful names of objects in the sky in the Mapuche language were chosen. These indigenous people live mostly south of Santiago de Chile. An essay contest was arranged in this connection among schoolchildren of the Chilean II region, of which Antofagasta is the capital, to write about the implications of these names. It drew many entries dealing with the cultural heritage of ESO's host country. The winning essay was submitted by 17-year-old Jorcy Albanez Castilla from Chuquicamata near the city of Calama. She received the prize, an amateur telescope, during the inauguration of the Paranal site. One of the large mirrors of the telescopes was the subject of an episode of the National Geographic Channel's reality series, World's Toughest Fixes, where a crew of engineers removed and transported the mirror to be cleaned and recoated with aluminium. The job required battling strong winds, fixing a broken pump in a giant washing machine, and resolving a rigging issue. The procedure is part of routine scheduled maintenance. ESO Hotel West Facade. The area surrounding the very large telescope was featured in the 2008 film Quantum of Solace. The ESO Hotel, the Residencia, served as a backdrop for part of the James Bond movie. Producer Michael G. Wilson said, "The Residencia of Paranal Observatory caught the attention of our director, Mark Forster, and production designer, Dennis Gassner, both for its exceptional design and its remote location in the Atacama Desert. It is a true oasis and the perfect hideout for Dominic Green, our villain, whom 007 is tracking in our new James Bond film." Over the past few decades, the Atacama has become home to some of the most powerful telescopes ever built. The European Southern Observatory's Very Large Telescope, completed in the late 1990s, was a milestone. With 4 massive mirrors, each 8.2 meters across, the VLT has captured stunning images of distant galaxies, probed the mysteries of black holes, and even taken direct pictures of planets orbiting other stars. But the story doesn't end there. Rising from the desert sands today is a new giant, the Giant Magellan Telescope. When completed, it will be the largest optical telescope in the world. Its primary mirror will span an astonishing 25 meters, made of 7 enormous segments, each polished to perfection. Together, they will gather more light than any telescope before it, allowing us to see deeper into space and further back in time. With this power, astronomers hope to answer humanity's oldest questions. How did the first galaxies form after the Big Bang? What is the true nature of dark matter and dark energy? And perhaps most tantalizing of all, are we alone in the universe? The Giant Magellan Telescope will be able to study the atmospheres of distant exoplanets, searching for chemical fingerprints of life. It's no coincidence that the driest desert on Earth has become the greatest gateway to the cosmos. The Atacama's silence, its emptiness, and its clarity have given humanity a gift: the ability to look outward, beyond our planet, beyond our solar system, and into the vast unknown. From the driest desert comes the clearest vision of the universe. The world's largest telescope is not just a machine, it is a promise that we will keep searching, keep questioning, and keep reaching for the stars. Subscribe to our channel for more such science-based videos.